Hi everyone, welcome to class. As I'm sure you already can tell, I'm not here today. The baby's sick, so I had to stay home with him until he gets better. So hopefully I'll be back in school tomorrow. And because I'm not here today, there is no warm up, so you can go ahead and skip that. All right, so let's talk a little bit about what we're going to do today. Before we get into the details, one quick reminder, make sure you've turned in the Investigating the Earth's Interior activity from last week. Your drill cores need your name on it and need to go in the bin up front. And then you also want to make sure you click submit for the Canvas document. Hey, make sure you get both of those in for today so that way you get full credit for all that work you did. Okay, so today we're going to be focusing on the different types of plate boundaries. You can see that in the agenda. We're going to start off with some notes, and then you're going to be mapping out their locations on that big map that you got from hopefully the front lab table. Okay, and then because it's Halloween, there is no homework for tonight. Okay, so at this point, I'm going to start doing my thing here with the notes. So you're going to want to take out your notes. I believe it's right around page 42. I don't have my packet with me at home, so if it's not 42, I apologize, but it should be right around page 42, I believe, is where the notes begin. And just a side note, period 2, I know you've seen some notes on Convergent already, so you can either listen again or you can kind of fast forward since we did a little bit of those Convergent notes on Friday. Okay, so by the end of the notes, you should have everything that you need for all 5 types of plate boundaries. Okay, so if you're going to pause to get your notes out, now is the time to pause. And when you're ready, you can click play again and see the notes. Okay, so here we go. Hopefully you're ready to go with your notes. And we talked a little bit about the convergent boundaries a bit with our warm-up on Friday. So remember, convergent boundaries are when 2 plates collide. And there are 3 types of convergent boundaries, and that's based on what type of crust is involved. So when you have plates colliding and they're both ocean plates or ocean lithosphere, then we call it oceanic. Both of these plates have a high density, but whichever plate is a little bit more dense, meaning it has a little more iron, then that's going to be the plate that subducts, which is what you can see happening in this picture if you kind of follow my pointer here. Okay, and when that subduction happens on the ocean floor, you get what is called a deep sea trench, which is kind of this huge, deep, kind of almost like V-shaped like valley in the ocean floor. It's very steep, very, very deep, and that's because of that subduction process. And then if you remember from our video last week, as this plate melts, and you can see it in the picture, the magma rises and you get a volcano. Now, since we're on the ocean floor, the volcanoes form volcanic islands. So I have a couple of examples. The one that's on the screen here says the Marianas Trench, and that's over by the Philippines. It's the deepest deep sea trench in the world. Another good example of this is the whole nation of Japan. Japan exists because of this process. If this wasn't happening, then we wouldn't even have Japan. Japan is a series of volcanic islands, and right off the coast is a very large deep sea trench. Another good example you can see in this picture here are the Caribbean islands. So if any of you have ever been to the Caribbean and have vacations there, you have enjoyed your vacation because of this process. There is a trench and all of those islands are volcanic. So this link here is just going to take us to a little clip of what this process looks like. And you guys have access to this in the daily slides, so if you want to play around with it yourself, you can. And this is going to show us the Caribbean islands. It makes kind of a funny sound because it's showing the plates moving, but that's okay. So let's just check this guy out here real quick and see these plates move. Okay, so this is going to be the Caribbean. And apparently that's supposed to be the sound of plates moving. So you can see that plate subducting. Okay, and then the plate is going to melt and it's going to fuel all the volcanoes that make that island. And if you want to see more of that, you can play around with it yourself. You have the link in the slides today. Okay, so back to the notes here. Where do we leave off? Sorry, guys. Okay, so the next type of plate boundary is almost identical to the one we just saw. This is oceanic continental. The features are the same. You get a deep sea trench. You have subducting ocean crust. The big difference is that instead of having two ocean plates, you have a piece of ocean and a piece of the continent. And you do get volcanoes, but since we're not in the middle of the water, you don't get islands. You get volcanoes on land. So a really good example of this is on the west coast of the United States. They're called the Cascade Mountains. You may have heard of Mount St. Helens. It's a pretty famous volcano out there. Also, my favorite volcano is out there. Maybe it's just because I'm partial to the name. Mount Adams is out there. Another good place to find this is on the west coast of South America, making the Andes mountain range. A lot of major volcanoes around the world are created from this process. So let's take a quick peek at this. You're going to, again, notice it's a very similar motion to what we saw with oceanic. So we'll let this play here real quick, and this is going to be in South America, so that example I just mentioned. Okay, so again, you've got that subducting lithosphere, you've got the trench, and then it's melting to make that volcano. Okay, and again, these happen typically right along the coastline, so they don't happen too far inland. Okay, all right, good, that paused. Okay, so let's take a look at our third type of convergent boundary. This is the one that's the most different of the three, and that's because when you have continental, an important thing that I want everybody to write down and make sure they circle and star and highlight and whatever is that there is no subduction. Look at that picture. There's no plate subducting, okay? And that's because the continental crust is so thick and the density is very low. So it's really not going to have a good chance to subduct. So no subduction for this particular process. That means there's no volcanoes. And what it does is it forms what we call folded mountains. Best example of this, Mount Everest. It's a part of the Himalayan mountains in Nepal, where basically India is crashing into the rest of Asia, and they are crumpling and folding and making that mountain range. So this process is ongoing, so Mount Everest is getting taller every day. Another really good example is one that's not too far from here, and that's the Appalachian Mountains. Now, they're no longer forming. The Appalachian Mountains formed about 250 million years ago, and that's during the time of a supercontinent called Pangaea. And at that time, Africa was crashing into the coast of the United States, and it made the Appalachian Mountains. So another good example of that. Okay, now on to our next one. Out of convergent here, we're going into our next type of plate boundary. Before I forget, this slide just again outlines that process of subduction because that's the big process going on at convergent. But again, this is just kind of stressing what I mentioned a few moments ago, that only ocean, and ocean continental have subduction. Continental does not. Okay. All right, so on to transform. And I would say transform is probably the easiest out of all of them because it's just two plates. You can see them in the picture here, sliding past each other. In this case, one's moving to the top of the screen and the other is moving to the bottom. And I would say the most infamous transform boundary is on the west coast of the United States and in California, and that's the San Andreas Fault. So I want to show you guys a little animation here of the San Andreas so you can get a better idea of what this looks like. So same website as before. Quick little clip. There's our sound effects. Okay, so this is on, of course, super speed. You can see the time lapse there. But since San Francisco and Los Angeles are in different plates, you can see that Los Angeles is on the move, and eventually it will be a neighbor with San Francisco, and then it will pass San Francisco because of that sliding process. So this is kind of an interesting thing going on. So if you want to see the rest of it, again, just follow the link that's in today's slides. Okay, and that's transform, pretty simple. The landform that it creates is a fault, okay, which is a big fracture in the Earth's crust. All right, and then the last type of plate boundary is called divergent, and it's the opposite of convergent. It's where the two plates move away from each other. Okay, so they're moving apart. Most divergent boundaries happen on the ocean floor, okay, like 99.9% of them. When they pull apart, they make volcanic eruptions. There's earthquakes, lots of heat, and the feature that they make is called a mid-ocean ridge. And a mid-ocean ridge is basically a chain of mountains on the ocean floor that are volcanoes. And these pictures really don't quite do it justice as to how big they are. But when you look at this picture of the map of the world, these kind of gray areas, all of them are going to be your mid-ocean ridges. So you can see we've got a big one going right down the center of the Atlantic Ocean. So let's watch how that process works for divergent boundaries. And they're using the Mid-Atlantic Ridge in the Atlantic Ocean as the example here. Again, we'll just do a quickie here. Okay, and you could see those plates moving away from each other. Okay, and again, if you want to watch more, check it out. Okay, and then the last type of plate boundary, also divergent, but once in a while, divergent will happen on a continent. It's very rare. We only have one of them in the entire world right now, at least, called the East African Rift Valley, where Africa is literally ripping itself apart. And the way I think of a rift valley is a baby ocean, okay? So the plates are moving apart, and this is how oceans start. Eventually, they'll pull apart enough that the ground will kind of sink and water will fill in the area and eventually form a new ocean. But this takes millions and millions of years. So again, the plates are moving away from each other. And this is how oceans start. Okay, and then over time, that water comes in and fills in the low-lying area. Okay. All right, so that is the 5 plate boundaries. The last thing that you're going to work on today is going to be the locations of where they occur around the world. I'm going to show you one, and then you guys are going to do the rest. So you're going to be using that big map that you got from the front lab table. Hey, notice my note here. This is something we're going to use the entire year. So take your time. Make sure it looks good. Follow everything carefully. Zoom in, zoom out, do what you got to do, okay? If we need more time tomorrow, then I'll give you more time tomorrow. I really want you to take your time with this. Okay, so on the back of the big paper, there is a key. I want you to follow my color coding. So we're going to start with deep sea trenches. They're going to be blue. And then the type of boundary they format is convergent. And I put OO/OC because that's ocean, ocean, and ocean continent, just so you can see what types. We're going to do magma type later, rock type. And we're not going to do all of these features because not all of them are plate boundaries, but we will eventually add them in when we get to oceanography. So let me show you what the map looks like. So you can see anything in blue on my map, okay, is a deep sea trench. And you want to color code yours in blue as well on your map. So you're going to make your map look exactly like mine. And once you've done this one, then you're going to move on to the next. The next ones can be found in the note slide. So you go back to the Earth 101 resources, open the slides, and you're going to find it. You're going to work your way through all of the landforms that are created by plate boundaries. So deep sea trenches, mountains, mid-ocean ridges, you name it, it's going to be in there.